Okay, so we are asked to solve this equation, 3 divided by 2x minus 4/3. Which x can I plug in such that I get the same value when I take 5 divided by x plus 3 over 6? So what we're trying to do is find the magical number that when you plug it in here and here, sometimes even two numbers, sometimes three, depending on how big the polynomial gets, that will make this equation true. And so the first thing you should do, I would recommend, is reduce any kind of fraction you can, just like before. 3 over 2x does not reduce. Minus 4/3, that doesn't reduce. 5 over x, that doesn't reduce. But 3 over 6 does. What does 3 over 6 reduce to? Huh? Close. 1/2, right? Right? So reduce fractions that you can. If you forget to do that, that's fine. Just your numbers will end up larger. Now your second step is to eliminate the fractions. So when I look at 2x, I want to get rid of 2x, I want to get rid of the 3, I want to get rid of the x, I want to get rid of the 2. And so the easiest way to do that is to just multiply everything in the equation by a certain number. As long as you multiply everything by that number or variable, it doesn't change the problem. So an example, to get rid of 2x, I'm going to multiply everything by 2x in the numerator. And we did a problem like this yesterday in another class, okay? Now let's see what crosses off. Don't the 2's cross off? And the x? That's exactly what you want. You want to eliminate the fractions. Anything cross off here? No? Here? The x? Here? The 2. So now all I'm left with is a 3. So what do you think I'm going to do now? Multiply everything by 3. 3, 3, 3, 3. And now these 3's cancel, correct? Now you're going to write down what's left over. Here, 3 times 3 is 9. Minus 4 times 2x, well that's 8x, equals 5 times 3, that's 15. Was there a 2 left over? I almost forgot that too. So be careful when you're crossing things off, because I did not cancel out that 2 and it almost looked like I did. So it's really 5 times 2 times 3 is 30, right? I'm glad I saw that. And then plus 1 times x times 3 would be 3x. Alright, from there we're down to a 2-step Algebra 1 problem. The rest should be a piece of cake. So you may recall from Algebra 1, when you have something that looks like this, you get all the x's on one side, all the numbers on the other. So an example would be, I could add 8x to both sides to get rid of those, and then subtract 30 from both sides. Well, let's go ahead and write, I don't want to do too much at once. 3x plus 8x is 11x. And then I would subtract 30 from both sides. So this is review from Algebra 1. 9 minus 30 is what, negative 21? And then you may recall to solve for this. And some kids, they like to rewrite it like this, which is fine. That is the same thing. And then you divide by 11. So x equals negative 21 divided by 11. Now, what you should always do when you eliminate variables is plug it in and make sure it's true. Okay? So you should plug negative 21 over 11 in for this x and this x. you usually don't have anything to worry about unless it makes it 0. Okay? So in this case, I remember I plugged it in and it worked. But let's say you plug it back in and it doesn't work, and that produces something called an extraneous solution. And an extraneous solution, and I'll just put the words up here. An extraneous solution, you should always check, plug in the answers you obtain back into the original problem, because it may not be an actual solution. So when you plug in -1, if that does not make a true statement, you would call it extraneous. Okay, I'll give you time to copy this down here in a second, definition, but I'm going to show you how you would plug this back in easily using the calculator. So I would say the easiest way would be to take this value and store it to x. So you'd go -21 divided by 11, and you're going to store, and there's a store button right here, store, and it makes an arrow. You're going to store that to x. Okay? Now x is -21 over 11 when you hit enter, okay? Which is -1.9, not 0.90. And so now you can just plug it in, 3 divided by 2x. Now, when you type fractions in, denominators always have to be in parentheses. So it'd be 3 divided by parenthesis 2x. And then minus 4/3. You don't need a parenthesis around 3 because it's itself. And I get the decimal, -2.11. Okay? Does that equal 5 divided by x? And again, I don't need parentheses around the x because it's by itself, plus 3/6. You see how both of those are -2.11? That means that that x value of -21 over 11 made both sides equal the same thing. So it is not an extraneous solution. Okay? It's an actual solution. But had we got two different numbers here, then that would tell you that either one, you did the problem incorrectly, or you would label it as an extraneous solution.